on this topic. In this session, we will go more in detail to hear about data harmonization in the energy sector and also spatial data services. But also, we will look at a very crucial aspect of the circular economy, which is the waste management. We were supposed to have two presentations on waste management, but so far, the third speaker has not showed up. So I suggest we start with the first presenter, and then we see if he will come. We will have, depending on the presence of the person or not, we will have 20 or 30 minutes per presentation. I would suggest the first speaker to use 20 minutes, and then we have some discussion at the end of his presentation. Pier Giorgio, please, Cipriano, from Data Group. Can you please introduce yourself and then start with your presentation?
Good afternoon, everybody. Let me try to open the second one. Okay. So, yeah. So my name is Pier Giorgio Cipriano. I'm working in Data Group Public Services. That is a private ICT company located in Italy. And since last year, we are involved in an Interreg Central Europe project called CitiEnGov. This is the agenda. So first of all, let me introduce you the overall scope of the CitiEnGov projects. The acronym stands for Cities for Good Energy and Governance. As you know, Central Europe projects are mainly funded for sharing, for having best practices and examples of actions already taken by different cities at municipal level. In this case, it is related to actions about energy efficiency policies already undertaken by different cities. One of them is Ferrara in Emilia-Romagna, Italy, and other ones are Ludwigsburg in Germany, Bydgoszcz and Grodzic in Poland, Weiss in Austria, Split in Croatia, and other regions in Hungary. So the basic project idea is that energy is not a vertical policy, but should be considered as an horizontal policy that influences in a direct or indirect way other policy areas. And given this assumption, public authorities, especially at municipal, urban level, play a key role in terms of facilitator for driving towards an energy transformation process. To achieve this, cities should set up, from an organizational point of view, energy units, so staff dedicated to analyze, to collect information and analyze this information using correct tools and adopting correct strategies to improve the energy planning and the energy policies to be undertaken at municipal level. One of the deliverables that have been defined in the project is strictly related to energy data, to energy-related data. So one of the first steps that we took was a list of surveys and questionnaires and physical and virtual meetings together with all partners in different municipalities to collect detailed information about technical details on data, energy-related data that are now available in their own context. So not just coming from the municipality themselves, but also from other level of public administration and also from private sector. So when talking about data, it is noteworthy that in the context of Covenant of Mayor that has been defined some years ago in an article by The Economist as the policy with the highest impact on climate change mitigation worldwide. In this context, the importance of using actual data and detailed data is highlighted in public documents like this one that was published some years ago at this address, eumayors.eu, how to develop a sustainable energy action plan, where they highlighted the importance of using as a source of data sources that are to be available in the future. This is obvious, but many, many times, almost always, sustainable energy action plans, at least in Italy, in the context that I know better, are only based or heavily based on statistics that are collected at regional level, and or data that are collected once to define the baselines, and are not easily cannot be easily updated. So it is important that during the preparation of these sustainable energy action plans, or what now we have the sustainable energy and climate action plans, municipalities focus on the processes of collection, of definition of data sources and collection of data. First of all, they have to be well documented, and data should be publicly available. These are sentences that are taken from this handbook, from this page 68. And another important sentence that I highlighted is this one: to think of initiating the energy management process within the territory, identifying buildings that consume most energy in order to select them for a priority action, based on a precise and detailed data collection. And it is noteworthy the initial sentence, now that this process of data collection may be the opportunity to deal with other important energy-related issues. A second reference document to be taken into consideration when we're talking about energy policies and data is this very useful and recent guidebook implemented in a European project called Data for Action. And it was very interesting to me when reading the first time this handbook to discover that even though they didn't went into technical details, they highlighted the importance of relying on European rules also about data to be based on Inspire directive. So in the list of European directives focused on energy, like the Energy Efficiency Directive, like the Energy Performance of Buildings Directive, and many others, one of the pillars highlighted in this guidebook is Inspire. This guidebook is very interesting because also clearly highlights the need for changing, for shifting from one approach that is usually happening in all the cities that are partnering in the CitiEnGov project, but also beyond the project itself. The model for sharing data is usually based on multilateral agreement between different partners, public authorities, having a bilateral agreement with individual data providers, and this is causing a lot of inefficiencies. And the shifting paradigm should bring to this model, so to the establishment of regional-based energy and greenhouse gas emission observatories. Some of them are already existing in Europe at provincial or regional level, where this central body can act as a facilitator for collecting, harmonizing, and sharing data at different levels, so from single buildings to administrative units. So, and in this case, I can give you just a very simple example. In the so-called Città Metropolitana di Torino, the former province of Turin, is one of the observatories listed in this guidebook, was able to collect from up to 60 different private utility companies the energy consumption from 2002 to 2013. So they really facilitated the work of the municipalities of the territory, that is, in the case of province of Torino, are more than 300. Many of them are very, very small, without any staff dedicated on collecting data. So this observatory was very, very helpful in the definition of agreement between data providers, in many cases utilities that are managing data about energy consumption, and public authorities at municipal level. In the case of Ferrara, in the case of, at least in many cases in Italy, the overall picture of data that are or can be useful at building level is depicted in these two slides, this one and the following one. So, since we are talking about spatial data, first of all, we have to start from geometry and topology. In the case of the Italian municipalities, some data are already existing and available at municipality level, so the responsible party or the owners are municipalities. The cadastre is instead available from the National Tax Authority, so the Parliament of the territory is part of the National Tax Agency. Information about the height of buildings, because we are focusing on energy at building level, we need also to consider the physics and the physical properties of building. Is it difficult or it is impossible to derive from the cadastre? The Italian cadastre doesn't have this kind of information, but it is possible to have it from usually from regional or municipal topographic maps. The energy bills, so the energy consumptions, are usually available to all municipalities and just to municipalities, again through the National Tax Agency that collects every single, for every single user, annual consumption for gas and electricity. The heating and ventilation and air conditioning system are, in the case of Emilia-Romagna, are stored and are managed at regional level. The age of construction of building is another missing information in the cadastre. We don't have a cadastre similar to the Dutch one, unfortunately. So we are forced to use information that is available from the National Statistical Agency. The energy performance certificates, again, are on a separate register managed in Italy at regional level. The information about local and energy, about the production of energy from renewable sources, for instance, solar panel installation, is managed at national level by a national authority called Gestore Servizi Energetici. So there is a quite huge heterogeneity and quite long list of data sources to be considered. I put also this slide because recently I came across with this report that was published on the European Commission website, and it is somehow similar to the overall objective that Inspire has, so sharing data. This is strictly focused on consumption data and deeply involve utilities. So the idea is to have a scenario in the following year similar to what is already existing in the US, thanks to a standard that is called Green Button, having a common data model, a common data format to be used between utilities that are, well, actually distribution system operators that usually are in charge of collecting, storing energy consumption data at various level of temporal resolutions, from minutes to months to 2 years, together with the final customers in a secure way, giving the customer the possibility to grant third parties, so also ICT service operators, to access his or her own data to provide informative services. In all this list of things, I also took an example about energy consumption data that will happen in an Emilia-Romagna region from next year. From next year, it will be compulsory for all distributors, for all energy distributors, to provide to the regional authority the annual data about energy consumption for whatever heating system, so being gas, district heating, GPL or other. And in the annex of the regional rule that define this mandatory request, I found the importance of the location, so of the spatial component of this data set, in basically in the codes that are used in Italy to represent the cadastral identifier. So we will have information at the point of delivery level with a spatial reference that will be made thanks to this external identifier. So we are approaching to something like this. This slide is taken from an activity that we are following within a working group related to the extension of the CityGML standard on energy domain. And when talking about data, we have to clarify, first of all, that many of these data are not available at building level. Usually they are available at a more detailed level, like the energy consumption. In this example, the unique building, we have a unique building divided in 2 different usage zones that can be then divided in different dwellings or different units. So, going back to the importance of collecting heterogeneous data and integrated them thanks to the spatial element. In the case of Italian municipalities, but in many other member states, I think it is happening something similar. We have different blocks of information that are derived, that can be derived from different sources. And the unique way to integrate them is thanks to the reference to addresses, to the cadastral parcel, or to building identifiers.
You have 5 minutes.
Yeah. So I will leave these questions to the floor. We collected these questions from the partners, from municipalities that are partnering in the CitiEnGov project. I think there are something more than 12. Okay, so they started to think of the importance of collecting data from heterogeneous sources, but also in terms of issues to be solved. And one of the issues to be solved is also related to methodologies, approaches, and tools to get these data, store these data into spatial relational database and transform them according to well-known schemas like the INSPIRE or the CitiGML Energy AD ones. Some examples. In the case of Ferrara, we already did something that was based on a previous project where we reused a pseudo-INSPIRE database implemented in the GISWASTE project to allow municipality officers to have, on top of just using a WebGIS application, precise and detailed information about single building units energy bills or single units energy performance certificates, and perform some analysis, some statistics. Of course, there are many other examples like this one that has been already implemented in Ludwigsburg by HFT Stuttgart, or like in Paris in the Accent project. And all these are examples of implementation at building or at building unit level, where one of the major challenge was the collection of data coming from different heterogeneous sources and the integration in an harmonized data model. So some conclusions, this is the last one, well, just two. Data source heterogeneity is the main challenge to be solved. The availability, the accessibility, but also the levels of details and licenses and semantics of data varies enormously country by country, but in many cases also from city to city. When talking about data about buildings, about the energy performance or the energy consumption of buildings, it is, of course, it is easily, this information, this data can be easily decoded, but at least in many cases in Italy, the quality of this data, so the quality of data coming from energy bills datasets or energy performance certificates is very low, and it is also important to think that these data are usually personal data. They refer to persons with names and surnames or person identifiers, so they have to be aggregating and anonymized before having them shared. CitiGML Energy AD and INSPIRE are for sure the two target schema useful to integrate these heterogeneous energy-related geodata. But this is not enough. Existing web services or platforms that have been already implemented in previous initiatives or projects like the one that we saw a few minutes ago about energy simulations should interoperate with each other through well-known GeoICT standards. To conclude with this picture that is not from my grandfather, even though there are some similarities, if we want to improve the energy efficiency in our buildings, in our cities, we have to measure them. If we cannot measure them, we cannot improve them. And I would like also to thank the following people that supported me and helping me in this presentation. Thanks.
Thank you very much, Pier Giorgio. I open the floor to questions from the public, if there are any. Martinus? Just a minute, there is a microphone coming.
Thank you. My name is Martinus Franken. I work for the Cadastre in the Netherlands. And I have a question about, well, you are putting together all these data now, which is giving a very interesting database, data set. And you can do many things with it after you improve all the quality. But I think it's also very important that you find out exactly what kind of information is needed by the policymakers or the decision makers. In my opinion, as I look in at the way it works in the Netherlands, if you ask them, they're not really aware of the exact information they need. So there's quite a process going on and finding out what do they exactly need and provide them, and then you start a new discussion. Oh no, but now I need this and now I need this. So it's not just giving them all the data, but really start working with them together to find the question they need. That's quite a. Is this? Have you seen this phenomenon also in this project?
Well, not yet, at least in Ferrara. That is the pilot case that I'm working with in a more constant way. In the case of Ferrara, that is a medium-sized municipality, at the moment we just interact with technicians, not with the politicians or decision makers. And the reason is very simple. Technicians are the guys that perform the hard work, the daily work. They suffer a lot of having a responsibility to, for instance, to provide numbers for the monitoring of the Sustainable Energy Action Plans. And they are not able to provide numbers because of the lack of information or because of the lack of tools. So we started to work together with them in the last year. So in 2018, of course, we will also start to talk with politicians. But it will be difficult for sure, because politicians usually talk different languages, of course. I just give you an example just to better explain what I mean. In the case of Ferrara, signed the Covenant of Mayors in 2012. The year after, defined its Sustainable Energy Action Plan with beautiful, wonderful actions listed. The problem is simple. Functionaries within civil servants within the municipality that are responsible every 2 years to provide numbers are not able, because they don't have the detailed information about, for instance, how many numbers of buildings passed from F class in terms of energy performance to B class, for instance, because these data are managed by the regional authority. Okay, and they have many difficulties in getting data from them.
There is another question then. There is a question related to this exactly. Do you plan in your project to find a way to not only technically but also understand how these different authorities can talk to each other? Is this one of the
core of the project is about providing and sharing examples, guidelines, and also templates of agreements. So it is not related. Indeed, this kind of project is not related to implementing technologies, but using technologies in order to better understand how it can work, and how the work of these functionaries can be facilitated.
Yeah, there is another question there, please.
Well, it's not a question, it's more an information. My name is Marie-Françoise Voitreau. I work with the Open Geospatial Consortium in Europe, and we have run last year a pilot called Future City Pilot 1, and to test interoperability, how to reuse the information which is provided in BIM standard by the architects to update the information that of the city, which is in CitiGML. And so this is an example of thing which has been done last year, and the reports will be released publicly very soon, so it should interest you. And we are right now gathering the requirements for a future City Pilot 2 to make some follow-up of this type of work. So if you're interested, we can discuss.
Thanks.
Thank you. There is another question from Giacomo.
Sorry, Pier Giorgio, based on your experience, now talking about the never-ending battle between energy consumption, measured data, and privacy barriers, would you be able to reply which is the minimum level of aggregation / anonymization to make the data aggregated and anonymized useful for analysis? Because, for instance, we have buildings in which there are tens of building units, but I don't know, maybe 10 buildings, 50 buildings. Have you any
Usually
idea?
census blocks that in Italy, for instance, correspond more or less in urban areas to to aggregation of buildings, to isolati.
Blocks.
Yeah, blocks. So with boundaries corresponding to streets. But to have data aggregated as a census block, you need to collect data at a more detailed way, because usually in databases used by or managed by utilities, there isn't any reference to any census block. The unique geographical reference is usually the address.
It's not possible, for example, to oblige to put the cadastral reference in all the permits, because in Spain we are obliged.
Yeah, in the case that I showed you before, it is foreseen the reference to the cadastral reference. Okay, it is, but this is something that will happen next year. At the moment, utility companies, distributor service operators usually have databases containing detailed information with a unique geographic identifier or element corresponding to the address. And it is interesting because vice versa, they are very hungry, they are very interested in having data coming from public sector. I was really surprised when looking at some WebGIS application that were implemented by a local utility in Ferrara called HERA. It was something like the examples, the pictures that I showed you before, but they took the wrong base spatial data sets from an old topographic maps. So they geocoded energy consumption, not at building level, but at building part level. That is useless, completely useless.
No. Well, there is another question, just a quick one, because then we have to move to another speaker, please.
You've shown my name is Ad van Houten, also from the Cadastre. You've shown a picture from, I think it's Ferrara, with the buildings in red and yellow and orange. And
this one.
Yeah, that's this one. That's a déjà vu for me. I've seen something like this in some 10 years ago in a conference of energy distribution companies in the Netherlands. They had a question about the city Groningen, Ferrara in Holland. Where are the houses with the highest energy leak, and what can we do about it? And they flew above Groningen in a cold winter evening, not at night when everybody sleeps, not in the morning, everybody's gone, in the evening, and with infrared. And the houses with an extreme high energy leak showed up. You categorized them. You had a priority on the parts of Groningen who had to be treated first. And you got a plan.
So you are meaning energy waste?
Waste, leak.
Energy that is wasted from the roof?
A leak through the roof,
yeah.
through single pane windows, etc.
Yeah, this is again another useful information. This map is just showing the normalized heating consumption at building level. So we don't know anything about energy that is wasted building by building. We just know that some buildings have an average heating consumption per square meter or per cube meter higher or lower than others.
Thank you, Per Giorgio, for this very interesting presentation that provoked interesting discussions. And I now give the floor to Alejandro Guinea from Spain.
Okay, good afternoon. I'm going to speak about the GISWASTE project, and I'm going to tell you already the message. The message is, I'm going to state the obvious, but it's not happening yet, is that we really need the geographic information to do real analysis, and it's not something that is easy nowadays when you are not in the mapping industry and you cannot access the data. I will explain what is the GISWASTE project, what kind of GIS analysis we made, what kind of geographic information we needed, and some conclusions. Okay, this is the GISWASTE project. It's to develop a GIS environment to decision-making support for waste management and to minimize the risk of implementation and new valorization plan. This project is a live project, about 1.5 million, and it just finished last June. I think it's important to say that we began this project in 2013 because the situation may change a bit, and maybe some of the information that we didn't find now is more accessible, but not really. We, I mean, the case study in the exact pilot project that we did to develop this tool, it was applied in the Basque Country, but it was very important to export this tool to another European regions. What we get is the organic waste, vegetable and meat, and what we want to produce is biogas and animal feed. In the Basque Country, there are about 4 million tons of this kind of organic waste. The main target of the project is to do the definition of all the factors that impact the feasibility of the different valorization options. And in the consortium of this project, there were a lot of experts of waste, organic waste, but none of them were using geographical factors. They were focused in technical factors, economical factors, environmental factors, but nobody in the geographical factors. But you know what can happen? That we need more energy to move the waste than the energy that we are going to generate. And it depends only about where is the plant and where are the waste. So the geographical factor is crucial to decide, to take a good decision about this. But they were not doing it because it's complicated. It's not that easy. We don't press a button and it works. And it's not easy because there is not harmonized geographical information mainly. So the geographical analysis that we did is like we put our assets, in this case the producers of the waste, organic waste, in a map. So we register the generation points. We create a scenario, choosing and filtering what are we going to use in the study. Then we filter one possible location for the plant and get the optimal location, and then we do a logistic calculation, which it ended as the most important factor to take into account, even more than the kilos or stuff like that. Okay, the first information that we needed is that where can we put a plant? And that was not easy at all, because first we needed the roads. The roads were not easy to get because there was not a transportation network data set. And then where can we put a plant? The expert decided that a good place is an industrial area with free space, okay? But again, was not a data set that you just go there and you get it, even you cannot buy it. So I'll explain how we got that information. We filtered that available parcels to which ones are close to the main roads, and we get these possible locations for the plant. Then we put all the producers of organic waste in the map, and taking into account the kilos of production that they have, we studied what was more or less the area where it is a good place to put the valorization plant. And then we did the logistic analysis. It's like, okay, I have to bring all the organic waste from these points to here. This is one of the possible locations. We wanted just one number. How many kilometers I need to go to drive with the cars, taking into account that not all the trucks can get all the waste, that a truck has a limit of 20,000 kilos, for example. Once it's full, I need to go back, and all of that. And with that number of kilometers, now we can go to do the economical study and how many CO2 footprint I'm going to save and I'm going to create because of carrying with all of that waste. Okay? So we needed just 4 or 5 data sets. Okay? The first thing that you have to do if you are doing any logistical analysis is to put your assets in the map. So you need cities, numbers of portals, and street. We didn't find it. We decided that it's impossible. If we want to put the producers in the map, we couldn't do it. I mean, we could buy TomTom or something like that, but it was quite complicated, and we wanted to reproduce this project in another parts of Europe, so we didn't do it. We decided that it was a good approximation to do in an easy way the postal codes, but we bought the postal codes. They were not free, and we needed to buy them. So fine, we have some tool to put all the producers or all our assets in the map. We paid, but it's fine. And then we need the roads, and there was not a transportation network again. Do you recognize this logo? It's OpenStreetMap. And we say, okay, let's go to use OpenStreetMap, because we didn't need a very complicated analysis. It's just more or less, you know, how many kilometers you need to. It's more complicated, the tool of network analysis that you have to do that. In this case, OpenStreetMap was good. We needed, I said, the industrial areas, and then we got to the regional government, and we used some compilation, all the urban plannings of the municipalities together, and from there we extract the industrial areas. And yes, the protected sites, it was ready in internet and GML and nearly harmonized it. And that was good because it was not a problem and all the processes that we developed for that specific data set, we can use it in all the countries. It was just about not putting the plant very close to a protected site. It was not very important, but you have to take that into account, because if not, you do all the study and they say, okay, that is really close to this green area. Okay. So what are the conclusions? That geographic information is mandatory for a real feasibility study. You cannot, you know, get lost in the numbers and play with energy and all of that, and then you need more energy to carry the waste that you are going to save. And for that, you have to do a geographic analysis. But geographic information is not accessible yet. It is a barrier. And as the previous presentation, each country has different scenarios. So we really need INSPIRE to harmonize that. And we are talking about basic data sets, okay, for geocoding, road network, something really simple. Any study, geographical study, will need geocoding and network analysis to do that. We spent a large effort looking for data sets, calling the regional government, knowing that it was a waste of time because that was just for the pilot project. But if we need to do that in, I don't know, in Alsacia, here, in Wallonia, or wherever, or in your region, it will be again, you know, to look for all those data sets. So we don't do it. These people, my colleagues, you know, engineers and waste experts and that, they just don't do it. They do a really good and nice study, but without taking into account the geographic part. And I really think that next phase of INSPIRE will boost this kind of studies, because in 23rd of November, we're going to have loads of harmonized data sets. That's what the directive says. Do you think it's going to happen? Yes? Yes? Yes, yes. Thanks to companies like you and mine, we are going to have it. Okay, that's all. Thank you very much. We have a booth there, so if you have some questions about this project or about the services of Geogramma, I will be glad to.
Yeah, but we will have some time also now. You can ask your questions already here, if you like.
I have a question. It's not about the technique, but more about the idea of building a central biogas plant. Did you also consider to make more in situ biogas plants close to the farms and to the places where the waste is being produced? Because this would cost you a lot of kilograms. You would lose them.
Yes, you try to balance between the kilos. Where are those kilos? Yeah. And you need a minimum amount of kilos to make it feasible, okay, viable, because in Basque Country it happened. There was this milk producer, okay, and it was the main producer of organic waste, and they shut down. So imagine you have there a plant, you know, a big plant, and they shut down. So you have to take into account where are them, but it's not the only parameter to take into account, because then it can happen that they move or the business change, yeah, and then you have a old, alone, isolated plant, yeah, there. Okay. Mm-hmm. Okay.
Is there any other question? Yes?
Alejandro, I would like to ask, did they ask you a projection, future projection? What happens if more places produce more wastes in the future? Is there a model for that? And will you need to search for addresses and make calls to the municipalities, etc., places again in the future? That's important for the sustainability of and sharing with the other countries of the tool. Is there anything like that?
Mm-hmm. Yes, the second, I want to, okay. The second question, yes, I mean, we are hoping that INSPIRE will publish harmonized data sets so we can export this tool to other regions or situations. And regarding the projection, the second step is to choose a scenario. That scenario can be what the producers that you have, but it can be as well what the producers that you may have or you can plan that is going to happen. So like that, you have like a limit when the plant will be feasible or it will be very expensive to maintain and that. So you can say with all these producers, for example, okay, it is good. I have enough kilos and I don't need a lot of kilometers to bring that kilos to the plant. But what if half of them disappear? or half of them have their own valorization plans and their own channels to use so you can see what's going to happen. So it's more, this tool is to help to take those kind of decisions. Thank you.
I have one question as well. It's me. Did you promote this to other regions already, or you are going to do this in the next
No,
months?
we just finished the project, and then we are in the part of marketing and all of that. But we are the GIS experts of this project, but the leader is now promoting it to other regions and to showing it in waste congresses.
So not only in Spain, but also in other European regions?
Yes, in the whole Europe. And then they have, the waste experts have another problem as well, how to get the information of the waste. Because, but that is another thing. It's like the energy, or we have our problems with the geographic information, and they have their problems with the waste information.
There is another question there.
So, do you also take into account the localization of the people who are going to reuse this information?
Not yes.
The waste, I mean.
Not in this case, no, because that you have to know very well the market of who are going to buy you the animal feed and all of that. So in this case, the stakeholders, they don't know that part. And the other is energy, you know, like biogas. I mean, it's not here. Biogas to generate energy, and that you can connect everywhere. I mean, you don't need to be close to the consumers of the electricity in this case.
There was another question from Pier Giorgio, I think.
Do you think, or have you already planned to replicate the same approach, the same analysis, using other typologies of waste, for instance, electronic waste, or?
Yes. This system, I mean, I only spoke about the geographical part, but there is a huge project behind about all the factors, economical factors and technical factors that you have to define your waste. How many kilos do you need? What are the conditions that you need to be used and all of that? And with all of that, you do filters, and it is open to any kind of waste, because it's about defining very well what do you need, then figuring out what do you have, and then you put all together and you get numbers that it can help you to decide.
So waste marketplace.
What?
Waste marketplace.
Yes. It's not the best one, but yes. Yes, it.
Are there any additional questions? No? So thank you, Alejandro.
Okay.
And now we pass from the circular economy to the we pass from circular economy to the Inspire Spatial Data Services, which is an example is presented by Daniele Francioli and Giacomo Martirano together. Sorry, I didn't know who was starting. They are both working for the Joint Research Center of the European Commission. We are part of the same team from the Digital Economy Unit of the Joint Research Center. We work on a project called the European Location Interoperability Solutions for e-Government. It's a project from the Interoperability Solutions for Public Administration program from DIGIT. And they are going to present an example of a spatial data service.
As soon as we will find the presentation.
Yes, I will help you.
Okay, test for my intelligence. Did not so well.
Please, Giacomo, the floor is yours.
Okay, thank you. I will share this presentation with my colleague Daniele. We are both consulting the GSC for this work. And I would like to start to take your attention about some keywords which are in the title of this presentation, because we have web applications for Inspire, which is something which is, I hope, not so used, because we believe to have made a good job for that. So web applications for Inspire. Then there is ELISE, which is another keyword, which is the context in which we made this work. And then the word pilot, energy, that I'm going to introduce in a while. And then there is another one, which will be covered in the end of the presentation, which is dealing with spatial data services, SDS. Which is a component of the overall Inspire burden, not yet exploited so far. Just to have an idea, may I ask you, can you raise your hand who has dealt with SDS, with the technical guidance and then implementing rules and technical implementation so far? Okay, so it's, Daniel, it's a good chance for us. So the outline, I will give just an overview of the ELISE Energy pilot, so the context, and then I will leave the floor to my colleague Daniele, explaining in more details the requirements, the architecture, the prototype that has been developed, and then a couple of slides about the Inspire Spatial Data Service concept applied with a real SDS metadata downloadable to make the web applications for Inspire, to make a web application for Inspire discoverable and usable, not only WFS or WMS. Okay, ELISE, I don't know if any of you had the chance to attend the workshop that was held on Monday afternoon in Kel, which was extensively presented. The acronym stands for European Location Interoperability Solutions for E-Government. So is an action, is a project coordinated by the GRC of another bigger program, which is called ISA Square. Stands for Interoperability Solutions for Public Administrations, Businesses and Citizens, which is a program of DG Informatics of European Commission running from 2016 to 2020. Just to introduce you, but what is it? This is a very structured and articulated picture in which you can, the intention is just to give you an overview of which are the outcomes and the products and the results of this huge action, studies related to the importance of the location for the interoperable solutions for businesses, citizens, and public administrations, frameworks, other kind of services, but most importantly, applications. And the pilot, in the frame of which the study is going to be presented, is related to these pilot projects of the ELISE, and one of them dealing with energy efficiency of buildings. There are other pilots in other domains. So diving now into this pilot project. Just an overview, the aims of these pilot projects are basically to use location-based data, so geospatial data, to support different stakeholders engaged in energy policy's life cycle. In the plenary, we learned from the speakers that geospatial data are crucial for generally speaking, in the policy domains. There are many policy areas in which geospatial information is already playing a key role, and we are focusing on the energy policy domain, and it's important to highlight in the whole life cycle. So from the policy anticipation to policy implementation to monitoring and reporting. In more details, the aim is to leverage location-based data at building level. You see this scale-up approach at building level as enabling factor to scale up the methodology to assess energy consumption and performance from local to district to urban to regional, national, and EU level. So right now, what's happening is that there are statistical data more or less retrieved or aggregated at national level and then downscaled, weighting them with the statistical information and so on. So the idea is to start with a bottom-up approach from the most detailed level achievable, which is at the building level, of even more detailed at building part and building unit. The specific objectives are to show the benefits of an integrated approach for reporting, monitoring, and planning to handle the multiple aspects of energy by adoption of common structured data models, which is one of the recommendations that we learned also from the presentation of Pier Giorgio and many other presentations heard so far. In this case, extending few inspired core data models in order to fit the needs of our use cases. And also common data access mechanisms based on inspired network services. The idea is to reuse the datasets or part of the dataset for different reporting, monitoring, and planning purposes. And the exercise was to go through the data flows required in several energy policies instruments, like directives or initiatives, and try to reuse part of the dataset for different, to gain efficiency in the use of the data. And then use both centralized and distributed IT infrastructures which make accessible data needed to fulfill all these requirements. So basically you see here the principle of Inspire adopted here. How the pilot is running is tested by means of a set of use cases which involve different actors, public authorities and regional and local level, businesses working in the energy sectors, and citizens, mainly building owners. And the work presented here is related to the first use case, which is called Inspire Harmonization of Existing Energy Performance Certificate datasets. I will stop here just to show you the workflow of this use case, because some more technical aspects related to the Inspire data model extensions have been dealt with in other floors. So we started from the availability of two different datasets. The dataset of energy performance certificates of a regional authority in Italy, and then which was not open, and then an open dataset consisting of cadastral vector datasets with the building footprint. So we are dealing here with 2D data, and that's it. We georeferenced the two datasets, creating one database. Then we created the target model, extending the Inspire core data model for buildings 2D, taking as much as possible attributes coming from CitiEnGov Energy ADE, but adding, we took also some of the classes in the draft extended data model of Inspire, and then we had to define new classes because in the Energy ADE, right now the aspect of the certifiers, for instance, of the certification itself is not yet covered. The transformation was made with AIL, the publication of the dataset. So the whole Inspire cycle, publishing a WFS, publishing an Inspire a dataset compliant with this extended data model and with Inspire core by definition dataset, using this dataset in a JS desktop application. But at that time, right now, a professional user is the main actor, and then with the step 9, now I invite Daniele to take my place, because in order to make this data accessible from non-GI expert user, a web application has been developed. So, Daniele.
Yeah. Thank you, Giacomo. I want to start with the feedback that we had on Monday during the ELISE workshop, that basically a lot of users are complaining about this complexity of geospatial data, Inspire data, that these kind of data are not so usable by non-GIS experts. And if you think about a desktop client that can handle this type of data, it's really more complex than a common web application that is used for example, like OpenStreetMap or Google Map. And so, in order to create something, a web app that is more easy to be used also by a non-GIS expert, reusing, of course, Inspire compliant harmonized data, we started to think about a user interface that was more simple than something that is on a client on the desktop. And thinking about this, in the end, we found out that an interface like, as I said, Google Map or OpenStreetMap was the most common to the user, because everybody can use one of these interfaces, web interfaces. Then we started gathering requirements. We have a specific type of data to be accessed. And we were also thinking about the elaboration that were eventually required to transform this kind of data to be used by a common libraries or common web libraries. And under the technical aspect, we have to use WFS 2.0, and the data format, of course, is Inspire GML 3.2, but produced using an Inspire extended schema that is basically the one supporting also the extra fields for the energy performance of buildings. And as I said, we decided to use a web interface, HTML5, and we started searching for open source web mapping library supporting WFS 2. This is a schema that show how we are dealing with this data, because we found out that open layers and leaflet are the most used web libraries. And the problem with that is that dealing with extended schema, I mean Inspire GML 3.2, but with additional fields, was a bit, not trivial. So we decided to create something that stays in the middle and works as a kind of proxy. So the requests that are sent to the server by the client application, the web app, is then passed through this proxy, and it is converted from the GML format to a GeoJSON that is that can be used by these web libraries. And then we have also to do a CRS transformation, always using an open source tool that is available on the web. Regarding the prototype, we are using the dataset provided by the energy, the energy performance certificate dataset that are provided by the APRI, that is the Agency for the Water and Energy Resources by the Autonomous Region of Trento. And the data format is in the Inspire GML, and we decided to create this web application using both of them, the open layers and leaflet, because in this way our aim was also to make this web application reusable by others, and in this way we allow more users to reuse our application. This is the application. I can show you a demo. Okay, as you can see, is a really familiar interface, because it is done in this case using OpenStreetMap dataset. But we have a constraint from the Commission to use not the common OpenStreetMap dataset, but the one provided by provided by the Eurostat. So here you can navigate like Google Map or OpenStreetMap in the application, and for each building, in this data set we have to use only public buildings because of privacy issues, and so we have only the public building in this prototype. And you can just click on the building and you can see all of the information that we have now. There is also something other to mention. We are also reusing the Inspire registry software in order to create an extended version of the Inspire registry that is handling this code list related to building type and energy label. Yeah, this is the energy pilot registry produced using the registry software provided by the JRC as well. As you can see, the interface is really simple, and we also used another base layer that is the Copernicus. Yeah, for this pilot. Then, once we have this application that is available, this URL is open, you can test it, and in the near future we will also provide this as an open source tool downloadable that you can reuse. Once we have this, we were also thinking, okay, but this is basically a special data service. So we decided to investigate whether we could present this web application as an example of Inspire special data service. And having a look at the latest guidance, the special data service guidance, we discovered basically that we were under the SDS special data service regulated by the interoperability implementing rules, and we decided so to follow this technical guidance to provide the second level, the interoperable special data service, so the second conformance level. And this special data service metadata is available also. You can have a look here. And well, maybe I can just show you. Is a metadata of the special data service, and that's it. If you want to know more about special data service, we are at the Inspire booth, and you can just ask whatever you want about this. Questions?
Thank you, Daniele. Are there any questions? We have 10 minutes, more or less. More? Yes, Martinus. Yeah. Thank you for breaking the ice every time.
Thank you. It's very impressive you've done there.
Yeah.
I have a special question about the map you showed about the EPCs.
Yeah.
And there you showed one of the buildings. It was a public building.
Yeah.
And there was a building type was classified like a multi-block or something.
Yes, we have it only in Italian now. Yeah.
But this classification, can you elaborate a little more about that? Because we are really interested into that. I understand that is an Inspire extended classification?
Yes.
Can you tell more about it, please?
Yes. Maybe Giacomo, you can say something.
You can go to the
Inspire registry. Yeah.
Registry. Because exactly the same thing that we would like to do in the second use case with you is to start from to use the extensibility of the code list at the lower hierarchical level, and these.
Maybe Giacomo, you can say something about the registry before. What is it? Because maybe not everyone is.
Yes, the Inspire registry is Okay, I can show you. We have the central Inspire registry that is basically a container for all of the code list and the themes, application schema that are used to reference. I mean, they are used in the Inspire metadata. I can show you something. Maybe in English. Okay, this is the central Inspire registry. We have different registers, and basically here we have a collection of all reference code that are used in the metadata of the Inspire datasets. And the other one, the one that I was showing you before, is this, that is an extended version of the Inspire registry that has more code list or reference code. Because
Can you
yeah,
click one level deeper then? We can
yeah.
see this classification, because I'm really interested in it.
There is some work still to be done, because after also to deal because this tool is capable to handle multilingual aspects, which is very interesting for us. And for the time being, from the software implementation point of view, because Daniel is taking here a part of that, we use the labels, not for the energy performance, the labels for the entries into the register in English, and then for the time being, the definitions are provided in the native language, which is Italian in this case, according to a law which I think is national and adopted by all the regions. But the next step is to translate these definitions, which are one step deeper than the simple labeling of the code list values, at least in English language, in order to provide some initial ground for comparison with the cases that we are, for instance, dealing with in the other use case in which we are facing the current, I don't want to say an issue, but it's a typical cross-boundary condition, which is different from one country to another, in which in the Netherlands you have a certain number of building types. In Germany we have more and more. So the idea is to, in order to do not break the interoperability, is that when Inspire allows to extend code lists, of course we will use this opportunity. And in the case of buildings, we have in many cases the possibility to extend at a narrower level. And so we will use that. In order to make a comparison here, maybe we can do later to be more precise in these kinds of multi-block.
Yes, just I want to add something. We reused the registry in order not to use, let's say, static or text identifiers. No, we use the registry because we are providing persistent identifiers for each of the building type. If you have a look here at the code list, typology edilizia is building type. You have all of the value that are possible to be there in the data set.
For the time being, these are in the national
yes.
Italian language, but we are going to provide in English also.
And this is a persistent URI.
Yes.
And if, as you can see, there is no reference to the language. So it is just a new, a URI. You can use it in Italian, English, it will be available. Just using a feature of this software that is content negotiation, you can ask it using the same URI but with different languages.
Just a second. In this case, the owner of the database of the certificates has codes for these building types. But then the codes are referring to of this law are referring to definitions and titles that we prefer to provide the self-understanding, at least in the national language, rather than codes.
And of course, this URI will be also used in the example of special data service that we provide, because in this special data service you don't have text field, but you have URI, so it's machine readable, let's say.
Thank you. There is Pier Giorgio first and then Volker. Please.
Yeah, if you could please go back to the web application.
Yeah.
One of the questions that I was mentioning before in my presentation that we collected in CitiEnGov was exactly at this level. The energy performance certificates are usually at building unit level. So in this specific case, the building that has been selected may have more than one certificate. How to correctly represent the energy class when probably in this case
I stop you. We were in a lucky case because in this case public buildings have just one unit. Yes, yes. Okay. When I mentioned because I remember we had some discussion that there could be a possibility starting from the certificates at a single building unit level to produce a sort of derived or average certificate at bidding level, weighting with volumes and so on. In this case, the local authority we are working with said that they are not willing to use this sort of average at building, but maybe find out a way in the application to distinguish somehow the different building units having the single certificate and not having a certificate at the building level.
It is also something that I haven't understood in the case of Energy Label Atlas web application, where you have the energy classification at building level. The building is represented as a simple 2D object, but units in each single unit is classified.
The label is issued on every unit.
So
yeah.
Yes, but the thematic representation at building level, at the whole building level, is it weighted by?
I don't know how they produce this exactly, but if they show it on building level, they had to calculate a new one. But I think it's normally done is to show this on the smallest building unit level.
But
mostly there are dwellings, and it's in case of apartments, it's a bit difficult, but all other types of dwellings in this atlas, it's easy to show.
By the way, because we studied and we learned a lot from the Energy Atlas website in the Netherlands, we have been inspired a lot before to start our the development. In order to reply to Pier Giorgio, because it's a 2D representation for the time being, so when you click and see one label, on the right side they pop up with if there are 7 units, you have 7 objects to be clicked and to get information. Of course, with no correspondence in the map because it is 2D, but you have all the list with an ID. Is the number / a letter, I remember. Civic number plus a letter. So we have 26, A, B, C, D, E, means 5 building units in the building of which you see the footprint.
Thanks. Please, Volker, your question.
This building type was a good example that it's not just about the language, but it's also about the semantics of what is
of course,
this building type. And I guess it's a very simple example to show this whole complexity of data harmonization or integration.
Yes,
because even in Germany we have in the EU catalog 5 building types, but there's a private company now having 10 building types. They are not subsets, but they are different.
Yeah, but
and then it's really difficult to come up with some European concept of
course
what building is.
As we is also written in the title, this is an example. This is a first prototype, and I think that the main achievement of making, if we compare the Energy Atlas of the Netherlands, which is very well known as one of the best practices, is perfect, but is not dealing with inspired data. This is a prototype exposing and processing WFS 2.0 data exposing GML 3.2 conformant to an extended data. So the complexity which are behind to make it working in all the cases are known, and we start with the simple cases in order to get energy and not be frustrated to start immediately with the most complex things.
Very good. And with this, I need to close the session. But first of all, I want to thank the excellent presenters. We were able to fill the session with 3 presenters and very excellent discussions. Thank you. And enjoy your coffee break. Thank you. Very interesting.